All right, welcome to the presentation on Kotlin for Java programmers. My name is Venkat Subramaniam. I'm going to talk about Kotlin, the language. Just a little bit, I'll talk about what are some of the reasons or merits of Kotlin, and then I'll talk about the features. We'll dive into and start using Kotlin for various little examples and see the features. So what is really Kotlin? Well, Kotlin is a statically typed language. That's the very first thing. Well, static typing as, well, not quite static typing as in Java, but static typing tending towards languages like Haskell and Scala to a certain extent. So it's really a statically typed language, which means we got really good type safety during compile time. And of course, Kotlin compiles down to Java, but also Kotlin can compile down to JavaScript as well. So there are people actually using it to compile down to Java. What I mean by that is compiles down to the Java bytecode, not the Java language, of course. And then, of course, it can compile down to JavaScript code, and then that's got some merits as well. Well, what are some of the reasons to really consider Kotlin? Well, some of the reasons is the language is extremely fluent. That's one of the biggest benefits of Kotlin is it's very fluent. It feels natural to write code in Kotlin. If you're used to a lot of other different languages, you will feel at home here. It is elegant, but one of the key things about Kotlin is it really brings wonderful features from several other languages. In fact, if you want to really think about it, imagine you take about 15 different languages and put them in a blender and turn it on and just ready to run for a few minutes. And then you turn off the blender, what comes out of it is Kotlin. So Kotlin really brings a lot of wonderful features from a lot of different languages. If you're used to languages like Python or languages like Groovy or Scala or even C# and JavaScript, you will see features from a lot of these different languages appear in Kotlin. So it really is the best of many worlds brought together. So you can enjoy the benefit of, if you're looking at some language and saying, oh, wouldn't it be so cool to use that on the JVM, well, that's kind of what Kotlin really brings to the table. Let's talk about how to really use Kotlin. I'm going to show you about maybe 3 or 4 different ways to use Kotlin, and then I'll settle down to one that's probably the easiest for me to do the demo here. The first is you can compile down Kotlin to bytecode, create a jar file with it, and then you can run it as a Java program. But of course, if you're going to run this as a Java program, the problem is when you run it as a Java program, it's going to still require the Kotlin library to run. Well, the good news is you can include that as a runtime if you're really interested. That way you can just run Java without really specifying anything extra because the jar file will get bundled with the Kotlin runtime library as well. So let's take a look at how we can actually do this. So to do this, I'm going to start with a single file right here. Notice the extension, the KT extension. So this is the sample.kt is the name of the file that I'm going to start with. It doesn't have a whole lot. So what am I going to do? I'm going to write the main function. Well, how do you write a function? Well, Kotlin wants us to keep in mind that writing code is fun, so they call it as a fun to write a function to begin with. So you say fun main, in this case, of course, arguments, and this is going to be an array you're going to create of string, let's say. And what am I going to do within this? Let's go ahead and print out, let's say hello, but let's go ahead and add to this arguments of 0. So we'll start with the traditional hello world right here. So the main function is receiving an argument, and I'm just printing out a hello and then the word given to us right after that. So how do we really get this to work? Well, the traditional way to do this would be to run the Kotlin compiler. Well, the Kotlin compiler is Kotlin C, just like Java C. This is Kotlin C. And then you're asking it to build the code sample.kt. You're asking it to include the runtime, but you want this to be bundled into a sample.jar file. Well, as you would see in this particular case, I don't have anything here other than that one single file. And I run this Kotlin C, and as you would expect, it creates a sample.jar, as you can see right now. But the sample.jar has been bundled with Kotlin runtime as well, so you can readily just run Java without anything at all. And then I'm going to say world right here, and you can see hello world being printed right there. So you're just running Java, providing the class path to the jar file, and then specifying the class you want to run, which is the sample.kt class. That's what it got compiled to based on the file in which the code we wrote is present, and then you're specifying the argument for it. But of course, if you don't want to go to that route, if you don't want to use Java to run this, you can actually just compile it using, again, the Kotlin C compiler. But notice this time I'm not including the runtime at all, but I'm putting the stuff into a classes directory. So let's go ahead and remove the jar file real quick. So what I'm left with is just the sample.kt, but this time I'm running Kotlin C, but I'm asking it to put stuff into the classes directory. So right there is the class it compiled. You could jar this if you really wanted to, but this time around I'm going to run Kotlin without the C, and I'm specifying the class path to where things are, and I'm asking it to run that, again, that same class, and you can see that's running. While this is very useful to take a lot of different files and compile them into traditional jar file, well, that's great, but I'm not a big fan of having to do all this work for little code that you want to experiment and play with. Well, this is where you could actually use the REPL as well. I'm a huge fan of REPL. So let's go back to this case, remove the classes directory, just leave that in there for a minute. But let's talk about REPL. So what is REPL? REPL stands for read, evaluate, print loop. I'm a huge fan of REPL. I use REPL in almost any different language I use. I'm a huge fan of automated testing. So I write automated tests. I write test and I write code and write test and write code. But even though that cycle is really short, I'm a man of impatience. I don't want to really write a test and then try to figure out what the code should be. I want to really experiment. So a REPL really gives me what I call as a micro prototyping environment where I can type in a little code and play with it. Well, it turns out Kotlin C, the compiler we ran, actually is a REPL as well. So I'm going to just run Kotlin C right here, as you can see. And at this point, I can simply type a little bit of code right there, and I can play with it. And that's Kotlin REPL telling us 3 plus 5 is 8, which is true the last time I checked. And similarly, I can go ahead and output, for example, hello right here. And that is the print out from the Kotlin. We can also do a little bit more if we really want to. For example, I can say list is equal to, and let's say list of, in this case, I'll create an A and a C and maybe a B, and then, of course, a D. And then, of course, we have a list of values given to us. That's the value A, C, D, and B, and D. But what I can do is I can import java.util.star, for example, and I can say collections.sort, and then I can pass the list to it just to play with it. And I can take a look at the list here, and you can see that I've played with it in the REPL. So you can experiment little things. Why do I like this so much? The reason I like this so much is, like I said, I use REPL in a lot of different languages. And one of the reasons I do this is when I'm writing my code, I'm not sure exactly what combination of things would work. I'll come in here and play with this really quickly, experiment, and then I will use the world's best technology ever invented, which is called copy and paste. And I can just copy this from here and paste into the code and move forward, so that becomes a really nice way to experiment and play with it as well. But my most favorite way to run Kotlin actually is as a script. This is one of the things I really like in languages like Python and Ruby and Scala and Groovy and so many different languages is that I can simply take code and run them as scripts where it makes sense, and that's exactly what you can do. So how do I really run the code as a script? Well, in order to do this, let's go ahead and rename the file sample.kt to sample.kts. So I changed the extension to a KTS extension. Sample.kts, let's edit that file, strip out a few things we don't really care about right now. So in here, notice that I simply have the println hello and then plus the argument 0. So that becomes a little script I can run right now. And at this point, all I'm going to do is to run again the Kotlin C, but this time I provide a dash script option, and then specify the script file name, and any parameters I want to pass right after that can follow that, as you can see right here. So we are running the little script right here, and at this point, you don't have to really go through any steps. There is no residues left in the directory. All that you have is the script, and then you can run them as a script directly. That becomes really easy to work with. In fact, that's what I'm going to do for most part right here. So going back to this code, I'm going to start firing it up right here in the IDE, and you can see that this is simply running as a script, and we're printing a hello right there from the Kotlin script. So I'm going to be running this as a script for the rest of the presentation. Well, there are some really nice things that you can quickly look into when it comes to Kotlin. Well, the very first thing here is that semicolons are really optional. So if you really want to go here and put that semicolon, because of the habits, you can certainly do it. But the good news is you don't need to really put that semicolon. Isn't that pretty amazing? Very soon, your pinky will begin to really shine a little bit. Because if you notice, this right pinky, the only thing we ever do with this is hit that semicolon. This is in a state of depression throughout its living, isn't it? Because all the other fingers do useful work, and then you just hit that semicolon with it. This one is retired from now on. It can just sit there and watch the other fingers work because it doesn't have to be, hitting the semicolon. So you don't have to really use the semicolon. That's pretty optional, as you can see right here. Well, of course, there are some really nice, sensible warnings that a Kotlin can give us. So, for example, one of the benefits of using a compiler is to really get errors and warnings early on so we can detect those and fix them in the code. Well, I'm a huge fan of automated testing, I mentioned, so I a lot of times write tests to know if my code actually works, but I'm not going to discard the power and the benefit a good compiler can give us, and so we can find out, errors, and I'm generally a big fan of treating warnings as errors, so if there's a warning in my code, I normally turn that into an error so I can quickly find out and fix it. So for example, if I have a function called foo, and I'm going to put an x over here, int, and within this function, all I'm doing is simply say foo called for a minute. Now I'm going to call the function foo, pass a value of 5. Well, notice that I'm not making use of the variable x at this point. Well, Kotlin will quietly kind of remind you of that. So if you notice there it says foo called, but it says warning parameter x is never used and points to that variable x and says, hey, you're not even using this variable, are you okay? Well, you're probably used to something like this. You're using JavaScript and using tools like ESLint. Well, this is exactly what the compiler gives you a little warning right now to say, hey, this is not being used. Did you really mean that? So you can quickly address that. And that really improves the quality of code so we don't accidentally use variables that we don't intend to use. But one of the really cool things about Kotlin is type inference. We know that even language like Java now has type inference, but Kotlin has type inference very similar to a language like Scala does. So let's say for a minute I want to create a greet over here, and I'm saying that this is a string is equal to, we'll say hello right here. And this is a string value, and then of course I want to print out the greet, as you can see, and I'm printing the value of hello. But I can say the greet is equal to, let's say, hi, and then once I change it, I'm going to print the value of greet right here. But as you know, in this case, we said what the type of the variable is. If you're used to Java a lot, this might surprise you, but notice how we are specifying the type after the name of the variable. So greet is the name of the variable, a colon, and then the type information. Well, why does Kotlin use this syntax? Quite a few other languages do this as well, but part of the reason for this is languages like Scala and TypeScript, for example, do this, and part of the reason is the language wants to emphasize that the name of the variable is much more important than the type of the variable. Now, this really comes back to culture and discipline in different teams. Some people would use absurd names like G and K, and that's really not a good programming practice. They want to emphasize you want to give really good name for variables. And once you give a really decent name for a variable, so much that the type is becoming so insignificant because based on the context, you can really figure out what this really stands for. So you don't have to really waste your time and effort trying to really specify the type when it's absolutely obvious. So in this case, of course, if you notice in this example, notice that if I were to try to set the greet is equal to a value of 1, this will become an error in the code. Obviously, you should not be assigning a value of number, integer, to greet, which is a variable of type string. Let's come back to this in just a few minutes, but going back to this code, look at this one line for a minute. Now we are defining a variable called greet, and then you gave a value of a type of string, and then immediately you assigned a value of hello. But we know from the context that this greet is going to be a string because we are assigning a variable of type hello. So it is really redundant, because why would you assign a value of string to something that's not a string? So it's absolutely obvious what the type is here. So in this case, as you can see, the type information is pretty known. As a result, we can just leave it out, and this is what type inference is all about. So in this case, when I run the code, you can see it works just fine. But make no mistake, the type of the variable actually is a string. So even though you don't really say it explicitly. So if you're trying to set the value to 1, you will notice that it says you cannot assign a number to a variable which is of type string. It rejects that. And as a result, we can see that the type was correctly inferred to a type string in this case. You can also look for the Java class and find out what the type here is. And that would be Java lang string type as soon as this defines it. Now, this is a compile time property. Unlike languages like Python, Ruby, and Groovy, where you could have dynamic typing, this is actually static typing. So this is decided at the compile time, not something that's postponed to the runtime after all. So that pretty much is decided based on the context. Now, of course, it's really easy to make sense out of this, because when you look at that line of code, ask yourself the question, does the compiler have enough information to determine what the type of this particular variable is? And if it is, it can infer that for you. Otherwise, you may have to provide that detail. So we talked about the type inference. Now let's talk about 2 different ways to define a variable. Well, the very first one we saw a minute ago is to use a var, as we can see. And then you can say greet is equal to hello, for example. And then I'm going to print the variable greet. And then, of course, I can say greet is equal to hi and modify the value of greet right there. Well, while that was possible to modify the value, the more and more we use functional style code, it's actually dangerous to create things that are mutable when you write functional style code. So as a result, Kotlin has yet another declaration. And that is called val. And when you declare something as a val, that particular reference becomes immutable. So in this case, line number 5 is going to be an error. As you can see, val cannot be reassigned, and as a result, you're not allowed to modify that particular variable. In fact, you cannot even set this back to the same value. That's not permissible either. So the point really is, it is really not reassignable, and as a result, that becomes a way to specify that something is immutable. So the question is, what's the difference between val and var? Well, here's a very easy way to remember it. Var is the keyword for shame. So the more var you use in your code, the more shameful we have to be. In fact, you can know that a colleague has done this. They don't make eye contact with you anymore, and you kind of figure out you used var in your code, didn't you? So you can refactor the code to use more val in the code. So definitely move towards using more val as much as you can instead of using var. Well, we will move a little forward. If you're used to languages like Groovy and JavaScript, this is going to look a lot familiar to you. And this is the template, string templates that you can use. So let's take a look at an example of this real quick. I say name is equal to Joe, for example. Now I want to print out right here, let's say hello plus name. And so in this case, of course, we are concatenating the name to that string called hello. We've all done this in languages like Java, but it doesn't really make us feel proud. This is not going to really be fun to write, and it's code that's really verbose and not very exciting to write it. Now, what we can do here is we can write the code a lot more elegantly. So notice, before we do that, let's go ahead and write this as a single quote real quick. And then, of course, in this case, I'm going to say name. And clearly, that name, single quote, is not a character, a string right here. So you're forced down to come to a double quote at this point. But given a double quote, not only can a double quote contain literal, but you can also put expressions within this as well. So notice that in this case, you can say hello $name, and you can just drop that right there. Unlike JavaScript, you don't need to have a curly around it. Curly is optional if it's a very simple variable that you're really using. So you said hello name, and it says hello Joe. On the same token, though, you can also put a curly around it, so that gives you the same result. So why would you really want to use this? Well, if you want to really perform an operation on this, for example, to uppercase right here, well, in this case, of course, you're taking the name, but you're converting it to uppercase, and that's not really fun to print it that way. You didn't really mean Joe.toUppercase. Well, this is where the curly really comes in. You're saying that whole thing is an expression, and I really want to print hello, Joe, in uppercase. So use the curlies when you put an expression. If it's just a simple variable, don't bother. Just drop it with a dollar, and you can be done with it. So that becomes a really nice way to write this string as an expression. Well, but you can also go to a nice little multi-line string as well. So what if you're creating multiple lines of text? Well, something along the lines of, let's say, message is equal to, and now you have 3 different double quotes. And then, of course, right here, this is a message, let's say, for, and then I can say name right here. Hit the return, and we can say created on, and then I could say today right here, and simply we'll say today is equal to, let's go ahead and just put the value June 12, 2018, and you can see that in this case we are creating a little message, and we can print out that message right here, and you will notice that it gives us the multi-line string very easily. So you can start with the 3 quotes and provide the multi-line string, but on the other hand, what if this you were putting this into a function? So for example, let's go ahead and say print, and within the function print, you wanted to really put this right in here. Well, clearly, if you call the print function right here, notice that in this case, it does print the result, but notice that indentation that you saw right there, which says this is a message for Joe, but there's a little indentation, and where did that indentation come from? Well, that indentation, unfortunately, came from here, but obviously, you could write it this way, but that's pretty nasty, as you can see, because you do want to preserve the indentations when you normally write this, because then the function looks easier to understand, easier to maintain. So clearly, you do want to provide that indentation. So what can you do about it? Well, you can use a vertical bar right there. So for example, if I were to put a vertical bar on a few more lines of text over here, now you can see that in this case, when I run this, it does print it with the vertical bar and the indentation, which is kind of nasty. But what you can do is you can say in this case, you can say trim margin, and you can ask it to run through a trim margin. Again, if you're used to language like Scala, you're used to this one. Scala called it as strip margin. Kotlin calls it as trim margin. And so in this case, you can do a trim margin. And in this case, of course, it assumes that the character to define the margin is that vertical bar. But what if the vertical bar is sacred for you? Maybe you want to use a vertical bar in your text, and you don't want to be bothered by it. Well, then you can use some other symbol, like for example, a tilde right now, and then you can come down here and specify that particular character that you want to use as the separator, and then you can, as a delimiter, and you can see that it's able to use that as well. So you can nicely provide the indentation for your text and create the multi-line string really nicely, as you can see in this case. So we saw the trim margin as well and how we can use that. Well, this is another thing that I'm really a big fan of when it comes to languages. Now, think of the 2 things that we normally have access to. I want you to think of the word statement. Just say that word statement. How do you feel when you say the word statement? It's like life was taken out of you, isn't it? It sounds so grim. I really dislike statements. And why do I not like statement? Because what does a statement really mean? A statement says, I will do some work for you. You say, hey, thanks, statement. That's very, very nice of you. What did you do? And the statement says, I won't tell you. I put it up there, go get it for yourself. How rude. That's what statements do. In fact, this is really sad, isn't it? Why? Because by definition, statements cause a side effect, right? So this is very grim if you really think about it. Statements cause side effect. The only statement that doesn't cause side effect is a statement that doesn't do anything, right? And every other statement will have side effect. So as a result, if you take a purely functional programming language, you will see 0 statements in it. I'm a big fan of languages. I program in about 12 to 15 languages, and one of the things I look for in languages is the style, the semantics, and not just the syntax. And one of the aha moments for me is to discover that there are languages out there with no statements at all. Because a functional programming language doesn't want to have mutability. Well, if a language doesn't want to promote mutability, how could it possibly promote statements? Now say the word expression. You feel the smile come out of your face, isn't it, when you say that word expression? It feels a lot light. Well, that's the beauty of expressions. Expressions do the work and return a result to you. Expressions don't cause a side effect. If you look at languages like Java for a minute, what does Java do? In Java, you have an if statement and you have a for statement. And the question is, why are those things statement? The only reason is because they said so, right? So there's really no reason for these to be statements. A lot of other languages use these as expressions, and there's benefits to using them as expression. So let's talk about preferring expressions over statements. So in this case, let's take an example of a function I want to create right here. And the function I want to create is going to be can vote, for example. It takes an age as a value, integer. And in this case, I'm going to simply say if age is greater than 17, I'll simply say please vote. Otherwise, we'll say else, we'll say not yet kid. So this is a little example of a can vote. I want to print out can vote and provide a value of 18 to it. And you can see how if is an expression in this case, because the result of the if expression was returned, it took the path of the first route, the then part, and it returned the value in that particular expression. On the other hand, if I pass a value of 8 instead of 18, you can see that it says not yet kid. So that's an example of how the if becomes an expression rather than becoming a statement. So that becomes really easy. We don't have to cause mutation in the code. So in a way, you could argue if kind of works like a ternary operator, which is what it is really doing, is returning one or the other path as a response to that particular call. That becomes a really nice way to write this. Well, talking about which, let's talk about functions. Well, let's have some fun with the functions. You declare a function using the keyword called fun, and that's basically what is used to define functions. One of the beautiful things about functions is the return type is actually inferred. So for example, let's say you're writing a function called greet. So I'm going to write a function called greet. This is taking a name as a string, and I can specify that the return is a string as well. And in this case, I can specify what the return type is. We could simply return, for example, a hello $name, for example. And then, of course, if I were to call this, I can simply say greet and then pass Joe over here as an argument. And of course, the result of this is it's going to say hello, Joe. But in this example, we worked a little too hard. You don't have to really say the colon string. But before we go, that is how you specify the return type of a function. In Java, we are used to putting the type in the front of the function. So where the fun is located, you would have said string. But in this case, you put it right after the parameter list. So once the parameter list is over, you put a colon and you put the type. It's actually pretty intuitive once you realize you specify the name of a variable, a colon, and the type. Similarly, you specify the function, colon, and the type for the return type. So it follows the same convention that the type follows what you are defining. But in this case, though, looking at this, Kotlin says, hey, look, I examine what's being returned by this function, and based on what's being returned, I know it is a string that's being returned, and as a result, that is optional, and I don't have to really specify it. Let's go a little further to examine this real quick. What I'm going to do here in this example is I'm going to say, just for our purpose, result, let's say string is equal to a greet, and then we'll say Joe, and I'm going to go ahead and print out the result at this point. I went to the trouble of defining the type for the result as well. Now I go back over here, and I remove the type, And you can see that that really tells us the string is the return type because this is returning a string and we are assigning it to result, which is a string as well. But on the other hand, if I were to go back here and return a 1, well, at this point, the return type of greet is a number, is an integer. Well, because greet is returning an integer, you're assigning it to a string, and that's going to cause trouble right here. So type mismatch, infer type is int, but the string is expected at this point because you're assigning it on the side. So you got to be a little bit careful when it comes to this. It is going to infer the type based on what you're actually returning. Well, unlike languages like, so the type inference in Kotlin is a lot like the type inference in Scala. Scala will infer the type of the return, but Scala will not infer the type of the parameters. You still have to specify the type of the parameters in Scala. This is a departure from languages like Haskell and F#. In languages like Haskell and F#, it's a little bit scary in my opinion because in those languages you can leave out the type of the parameters, and what the compiler will do is it will start digging into your implementation and come out and say, ta-da, look what I found. Based on what you're doing in the code, I figured this name is a string, for example. That's a little unsettling for me because that is way too much dependent on the implementation, and the slightest change in the implementation could potentially change the type of the parameter you're passing as an input. So even though I love languages like Haskell and F#, I'm not a big fan of that particular feature. I think this is pretty well balanced. It allows you to treat the return, infer the return, but it requires that you pass the type for the parameters in this case, and that's what you're doing right now. So in this example, as you can see, we can leave out this type and we can simply specify the equals. When do you specify the equal? The equal is very useful if you're writing a single line implementation. So if your body is so small, you don't have to put too much effort into writing the body. Just drop that little one-liner and be done with it. That can reduce the noise pollution. You don't have to put a curly around it. So that is basically where you're using the equals to return it. But of course, you can specify the return type as well. But what if you want to, and we did a few minutes ago, but what if you want to return a void function? Well, if you want to write a void function, we don't call it void in Kotlin. It is considered to be a unit type. That's what it is. So you say the return type is a unit. In this case, I'm going to simply say output, and we will simply provide over here, let's say hello $name right here. And now at this point, I want to call the greet function and pass Joe to it. And you can see that in this case, there's no return type from this function. What if I try to assign this to something? So if I say result is equal to, let's say string is equal to greet, well, in this case, you get an error saying infer type is a unit, but you're trying to assign it to a string that's not valid, and that's what you're getting. But of course, the question is, what if I leave out the string right there and assign this to a result? Well, unit, of course, and you're saying result right here, and then you can see that in this case, it is just a unit. Now, that might surprise you just a little bit, right? And you say, gosh, if it's a void method, void function, why am I able to receive the value? I want you to go back and think about what we talked about a few minutes ago, and that is expression over statement. So expressions always return something. Well, a void is an expression as well. It returns a unit, so it behaves as an expression, and as a result, it wants to treat as many things as expression as possible. That's part of the reason why that behaves that way. But having said that, there is something really exciting about what you can do here in Kotlin, and that is default arguments. Why would you want to use default arguments? Well, oftentimes people tell you they want to use default arguments because they want to reduce the amount of code they write. I beg to differ. That's not my primary reason to use a default argument. I say that I want to use a default argument because it helps me to extend my code. Let me make the point right here why I mean that. So So let's say for a minute I've written a function over here called greet, and the function greet takes a name, which is a string, and within the function, all I'm doing here is printing, let's say, hello, and then I'm going to print the $name right here. So I call the greet function, and I pass Joe again to this, and that works just fine. But maybe a few weeks goes by, and you decide that you really want to not print hello all the time. You want to extend the code to add a new parameter, which is a message. How sad that is, because if you now come here and say message is a string, your existing code is going to break right now because it's going to require 2 parameters. This is one of the reasons I like default parameters, because default parameters is a nice way to extend existing code. Extensibility matters a lot for me. So I can simply come here and say hi right now. And notice I will quietly change this one. If I had used a hi in the first place right here, without the message, for example, then I can say, you know what, I'm going to pick a default right now. Whatever the default is, I was using hi in the first place, so I'm going to say message right now. It is a string, but I'm going to give it a value of hi right now. So if you're not providing a value, it is going to take that parameter value. So in this case, I'm going to simply say message. And as you can see right now, the hi becomes the message. But of course, I can call greet right now, and I can say Jerry, and I can say hello. And you can see that in this case, it says hello, Jerry, and I can use this. Of course, if I call greet with Jerry, but nothing as a second argument, you can see that it says hi, Jerry. Now, while that's really cool, if you're used to JavaScript, you know one other feature in JavaScript. This is a little wicked, but a lot of things are wicked in JavaScript, you know this. But what you can do is you can use the parameter to the left on the parameter to the right, which is kind of cool in my opinion. So what you can do here is right in the default argument right here, you can, if you want to, specify $name, and you can use that piece of information right there. So in this case, I'm going to say length right here. Did you notice what we just did? We just used name.length. Well, obviously, in the first case, you're specifying hello, and as a result, it will not use the default value that has no place at all. But on the other hand, in the second case, you're not specifying the default value. You're not specifying the value, so it's going to kick in and use the default value. However, the default value is hi followed by the name.length. In fact, that's how you can actually say hi-fi to Jerry and give him a hi-fi. So the point really is you can use one parameter to build another as well. So this can become really interesting way to build your API. For example, let's say that you are having a computation where by default the value here depends on some value in here. You can build that into your code very nicely. So when defaults are being used, you can leverage that as well very nicely. And that's exactly what you're seeing right here, is an ability to make use of that little nice information. Well, not only can you do this, this is another feature that I'm really excited about in Kotlin. Kotlin really begins to play with you. This is one of the things I like a lot about a language, where a language becomes very natural to use. You may say, gosh, there are so many ways to do this, and that can be a little intimidating and a little confusing in the beginning. But the beauty is when you want to really work with the language a little flexibly, it's nice when the language flexes with you. That's really nice. So in this case, you can use a named argument as well, which is something that I really like a lot in terms of how you can actually make use of this. So I'm going to say greet, and I will say name right here, and name is going to be equal to, let's say, Joe. And then I'll say message is equal to, let's say, howdy. So you can see in this case, I'm going to specify, let's say, Jane here, and it says, howdy Jane, really nicely. So I'm giving a named argument. Why am I a big fan of named arguments? Because it becomes really easy. When you have multiple arguments which are of the same type, the code can become a little confusing. How many times have you seen a method call where you say method name parenthesis 7, 72, 58, and you're like, what the heck do these numbers mean? That can be a little frustrating. I'm a big fan of self-documenting code where the code is very expressive, so you don't have to put a silly comment next to it to say what these values are. It becomes really easy to specify what those things are. That's one of the reasons I really like it. But what's really cool about this is you don't have to follow the order. So I provided a message right there, then I provide a name after that. As you can see, that's perfectly fine as well. So you can put them in any order that you want to based on what you are really comfortable with. Even better, you can mix and match. You can provide some positional arguments and then named arguments as well. So for example, in here, I can say Jane, comma, and then I can specify just the message as a named argument. And as you can see, the first value that I'm going to specify right here is going to go to Jane, but the second argument is for message because we gave a named argument for it. So you can specify positional and a mixed set of values as well. That becomes a really nice way to specify this, so you can mix and match that. Well, the last thing I will mention here, right here in terms of functions is another really nice, interesting feature, which is var args. So to understand this, let's create a max function where I'm going to take numbers, but this numbers is going to be an integer, but I want to specify maybe an array of numbers. But if I specify an array of numbers, when you pass the parameter, you have to pass an array, but I really want to pass discrete values to this particular function. So in this example, let's say I want to take the numbers as a parameter, so I'll say var arg to this, and now I can say equal to numbers, and what am I going to do with these numbers? I'm going to write a little code to get the maximum out of this. I'll say reduce, and the reduce function, I'm going to say max comma element, and then I'll say if max is less than element, then return the element, otherwise maybe return the max value right after that. So what I did right here is write the max function with var args. So as a result in this case, let's go ahead and say max with a 1 and a 2. And clearly in this case, 2 is bigger than 1. We got the result of 2. But if I call max with, let's say, 4 and 3, 4 is greater than 3, so we're getting the result of 4. But I can also say max with, let's say, 2 and 7 and, let's say, 1. And obviously, well, maybe I'll provide a 8 and maybe a 1. And you can see that 8 is bigger than any other value. We get back an 8. But however, what if I have something like this where I say list is equal to, and in this case, I'm going to create, let's call it as values equal to, and I'm going to create maybe a int array of, and in this case, I will create a bunch of values. Let's say 3 and 7 and 9 and 4, and I want to use these values to get the result out of it. Well, to keep things a little easier, let's get rid of those, and let's go ahead and call the max function, but I'm going to pass values to it, and what's going to happen at this point? Well, notice an error on line number 6. Type mismatch infer type is int array, but an int was expected. Now, how do I really solve this? One way to solve this is you can say value square bracket 0, and then comma value square bracket 1, value square bracket 2. Anybody excited about writing this? Because the minute you write this, a comment will be, I need another job, right? Because you don't want to be doing that. That's so boring. Well, what can you do better than having to write this? Well, the beauty is you can explode that with a little star in front of it, and now you can keep the job. So the point really is you can do an explosion on that. Notice it gave us a result of 9 at this point. However, what is really cool about this explosion or a spread operator is you can mix and match this as well. So for example, if I say a 10 comma, let's say 2 comma, and the values, obviously 10 is bigger than 9, so you got that value right here. Or you can say comma 22, comma 7, and absolutely 22 is bigger than any of the other values. So you can put things ahead of it, and you can mix and match it as well. That becomes a really nice way to build up your spread operator. So you can use var args, and you can use spread as well pretty nicely with it. So this becomes a really nice way to provide for your syntax into providing the functions with quite a bit of flexibility. So this is one of the things I often say is a language will feel right. And that is the thing I would say. It just feels right because it does sensible things for you. And I wonder this a lot of times, because when you are using a language, does the compiler really help you a lot, or does it insist a lot from you? That can be a really nice way to become fluent. Clearly, with a lot of these features, there's a learning curve to it, but as time goes on, it becomes a lot easier because the language becomes a lot more flexible to work with. So let me wrap this up with an example of the for loops right here. Well, what if I want to really iterate through for? So I can start with for, let's say x in, and 1 to 10, and if you're used to Ruby, that should look a lot familiar to you. And notice in this case, we have 0, 1 through all the way to 10. Now, you may be curious when you looked at this and said, oh my goodness, wait a minute, Venkat, you did not say anything in front of x. Is that a var? Is that a val? What is it? Well, you know that in JavaScript, this is not a val, this is not a var, it's a disaster. Because in JavaScript, it becomes a global variable. So my senses immediately perked up looking at this. I'm like, oh my gosh, what am I doing? Am I doing something really bad here? So a val over here, notice the Kotlin compiler says, no, don't do that. Well, what if I say var? It says don't do that. There's a reason for it. Because what is the most sensible thing about x? The most sensible thing about this variable is it should not be mutated, because mutating that variable leads to errors in code. You don't want to do this. So if you tried x is equal to x times 2, Kotlin gives you an error that says, are you kidding me? Okay, it's equivalent of that. So it says val cannot be reassigned. So that shows us that this variable is actually immutable, which is the really sensible thing to do. I'm really happy that's the way it actually works. So in this case, you went from 1 to 10, as you can see. On the other hand, I'm going to say until, and this is going to be one shy of it. Notice it doesn't include 10, it stops at 9. And of course, similarly, you can do a step over here too, and notice that it skips some values in between, and you can do a step value as well as you are writing this, and you can see how it is skipping the values right there. Similarly, you can start with a 10 right here, and you can say down to, and let's say 1, and you can see it goes from 10 to 1, but again, you can do a step 2 on this. As it counts down, it's skipping the values, so you can write that in a very nice, sensible way also. So we saw these things where you can use the until and all these wonderful things. We can also iterate over the values as well from a list. So for example, let's say a list, let's say names is equal to list of. In this case, I'm going to say Tom, let's say Jerry, and then let's say Spike, and I want to iterate over these values. So we can say for name in names, and at this point, you can simply print out the name, and so easily, knowing that it's immutable, you are able to do that very effectively. That's a for each where you can just iterate over it. But of course, there are times when you really want to work with the index value. So how do you really get the index value if you really wanted the index? Well, that's where the indices nicely come in. So you can say index, and in this case, you can say names dot indices. And at this point, your value that you are getting out of this is the index value. So you can pretty much print the index. So if you really wanted to print the index along with the value, you can do that very nicely, as you can see. So a dollar index, a double dash, and then a dollar, and then I could say names.get for that particular index, and I can get the value very nicely here, as you can see. And that gives us a nice way to go through an index as well. So very sensible looping, as you can see. So we are about halfway through what I wanted to cover. Well, that's the reason why this is a two-part session. So if this is something that's interesting to you, I've got a lot more to talk about. Hope to see you right after lunch. Thank you.